the exam that we covered. Okay. And that's a good review for everyone. So I would like everybody to pay attention, please. All right. I'm not going to cover the precise question because you're supposed to do it on your own. But of course, you're more than welcome to ask a specific question anytime. I'm going to cover what I've noticed is important, okay? And many have missed. Okay? So sort of the common theme as far as the exam is concerned.
Oh, no, I'm sorry.
As I cover a question, if you something you want to ask that pertains to a specific question, by all means.
Yeah, turn off the monitor.
Absolutely. Please turn off your monitors. Everybody again.
For Mrs. Allen, please.
All right. Here we go. So this is exam review. Maybe I should actually change so that we can we'll grab a different marker. I'll do it right. This is all right. If we're going to look at the following function, f of x equals, let's say, x minus 1 over x plus 2. A rational function. And the question is, okay, A, f of x equal to 0. We want the answer. What would be the answer? F of x equals 0. What's the answer? Say it again.
One.
Negative 1 half.
See, some students barely know it. Okay, and those who actually know it, they are afraid to answer it because they are not too sure. A fraction is 0 if, I can't hear you. If the top, the numerator is 0. So this is equal to 0 when the top is 0. So x is what? 9. Now whether it's a linear equation, a linear expression at top, or nonlinear doesn't make any difference. The top is 0 is the answer. Does that make sense? When is f of x undefined? When the denominator is 0, so x plus 2 is 0, which means x must be what? That's all there is to it. I mean, it's a split-second answer. When you're looking at a rational expression, the denominator can't be 0. If the function is 0, that means the top must be 0. All right. The second concept that I noticed dealing with some basic stuff as far as rational exponents is concerned, also when we take a root. So as I mentioned, I'm going to repeat the same question here. What's the answer to the first one? Why? Why is it negative 2? Because you can raise 2, negative 2 to the third power, and it becomes what? Negative 8. In fact, what is the cube root of 8? Is 2. And I went over the graph, if you remember. And there is a reason I went over the graph, because the domain and range, there was no restriction. That's why I said if you want to learn algebra right, and you're looking at a specific function, all those elementary functions, you have to know and remember the graph, because it gives you everything you need. Domain, range, x-intercept, y-intercept, you name it. So when I know a cube root in general, an odd root doesn't have any restriction, then negative, negative comes out, positive, positive comes out. Now what is the square root of negative 4? Not a real number. And now we know it's equal to what? 2i. Still many people manage to get this wrong. So you want to be careful with that. You shouldn't really make that mistake. All right. Since we're dealing with that, I thought maybe I want to put this up also. (25/36 to the power of negative 1/2). We want to simplify. We want to come up with the answer. What do we do first?
36 over 23.
We change the exponent to positive by flipping over the fraction. Negative exponential. Then we rewrite this as a radical form, and it makes it easier to follow, and the answer is what? I can leave it like that, write it as a mixed number, it makes no difference, but those are the steps we need to take. All right? Okay, with that, maybe I continue on that thought since I started with these roots and radicals. Let me continue with this concept. All right. Let's look at this easy case, because many people had problem with an example like that. Okay. Now, you can do the foiling, but you don't have to, because all of you are supposed to know what? Special product or special factor, in this case, special product. This is what? A minus B, this is A plus B, isn't it? So the answer is A squared minus B squared. When you don't use special product, it makes it more difficult to get to the answer. So this is what?
9x squared.
9x squared minus what?
4y.
And square root of y comes out. Becomes simply y, right? Simple, using the techniques we have learned, because part of the problem becomes timing. We should be able to do this fairly fast using the new, if you can call it a new technique. New techniques when we learn it, okay? Also, I gotta mention class. I think I mentioned in the beginning of the class, the core of the intermediate algebra course would be what? Functions, quadratic functions, logs, logarithmic, equations and properties, conics, because those are the new stuff, and that's what we are getting into. All right. Okay. The next one would be this. Okay, you are going to distribute. You can take it out just, I mean, you may see that the product is 9x squared and comes out as 3x, or just they are identical, so it comes out, right? Either way, in other words, 1 or 2 steps. You might try fast. Either way is fine. The next one, the same thing. You can see what? We have the 2, you can do it in 2 steps. We have the 2, and then we have the square root of what? 3x squared, or you may see that what? What comes out? X comes out, so 2x square root of 3, or 2 square root of 3x, or that's it. I mean, you can put the x in front, that's not a good practice. You take out a perfect square. That's all there is to it from the red. Now with that, let me add also this one. Something similar to that. Okay. To rationalize, to simplify, to divide, they all mean the same thing. You multiply by what? Right? Does that work? So let's look at the top only. When you multiply these two, what do you get? 3. And then you're done with the top, right? What about the bottom? The bottom is what? A plus B times A minus B. The answer is A squared minus B squared. Isn't it? Does that work? And so we get this one, which we will change. We will not leave it like that, right? You don't want the denominator to be 1 or negative. But up to here, it makes sense to everybody, right? So what happens next? What is this equal to?
-3.
So this -1, you can bring it up by multiplying by every piece up there. It doesn't matter if we have 2 or 10 terms. We multiply it by negative, that means we change the sign. Does that make sense? All right. All right. You have 2 choices, class. You can simplify inside, which is the order of operations. Or you can apply the 10. And I'm going to do both. If you are consistent, both of them gives you the same answer. Sometimes one is faster than the other. Okay? But if you do the order of operations, you can never go wrong. You know that, right? So if I want to go with the order of operations, in this case, believe it or not, the other method is fast. But let's do the order of operations just for the sake of argument. Do you see that this becomes what? x to the power of 1/5 minus 1/10, and the reason we do it this way because we know 1/5 is larger than 1/10. If we want to do the order of operations, this remains. And then you have y to the power of 7. This y to the power of -7 also goes down, becomes y to the power of +7. It's unfortunately a common mistake. If you look at your papers, some students have a problem with that negative thing. It moves up, you know, before you do the, or down for that matter. The sign changes. So do you see that the top becomes what? What is 1/5 minus 1/10? I'm going to assume we can add and subtract fractions. And that's your formulas. In this instance, the second method, applying the power rule first, would work faster. So let us do that. If we multiply everything by 10, do you see what happens this one to this one? 1/5 times 10, what's the answer? 2. Y to the power of -7 times 10.
7.
You're done with the top. You see that? X to the power of 110. 110 times 10. 1. And then y to the power of 7 times 10. So do you see this comes down, becomes +70. You get y to the power of 40, x squared, and x cancel each other. They give us x only at top. The same result in this case, if you went this route, would take less than that. However, if you ever doubt yourself, just follow the order of operations. Simplify what's inside the parentheses before you move on. Okay. If you're not dealing with rational exponents, this may be the better way. All right. Any questions so far? All right. Let's also look at the following complex fraction, complex number division in this case. And it's just that radical that we had in order to rationalize this, what do you do? This is different than what you had in the exam, but it's very similar. You have to multiply by the complex conjugate, which is 7 plus square root of 5i. Right, 7. Where did I get the 7
From the top.
from? Okay. So that would be, of course, this fraction class is nothing but 1, right? Because the top and the bottom are identical, so that's okay. That would be the complex conjugate of the denominator, 3 plus square root of 5i. Now, I have told you many times, don't multiply by, just write it as a product class. And notice I put the I far away on purpose. I don't want anybody to be under the assumption it's under the radical, because that unfortunately happens sometimes. If I want to multiply the bottom, this times that, remember this. We went over a plus bi times a minus bi, and we said that's a squared minus bi squared. Do you remember that? In other words, we proved that is a squared plus b squared. Do you remember that? Now you can use that, or you can go through these steps. So if it's a squared plus b squared, what is that? 9 plus 5. Do you see that, everybody? 3 squared is 9, isn't it? Square root of 5 simply comes up to be 5. And then because it's minus and plus, it simply takes the plus sign in between. And here's the proof. Or do the foiling, which is not a good idea. Just or do instead of foiling, actually you may do just a squared. This is first. A squared minus b squared, which gives you 9 minus 5 I squared, isn't it? And I squared was what? Negative 1, therefore plus 5. Okay? Now, what is the denominator equal to, everybody? I hope you see why I didn't multiply the 7 through. Because if I did, I may not notice that the 7 drops. Are you with me? And so, if I drop the 7, this becomes 2. And so I'm going to rewrite it as such. Now, you could leave it like that, and I'm okay with it as long as you understand the meaning of A and B. Remember, a complex number is in the form of what? A plus bi. So, to make sure everybody understands what is A here, class? What is A?
3 over 2.
3 over 2. So it's 3 halves plus square root of 5 over 2i. Does that make sense to everybody? If we can see that, we can leave it like that, but don't take a chance. If they ask you to put it in standard form, it means put it in A plus BI format, and that's not finished. That's not a finished job. And mostly, that's what they want. I'm okay if you understand it, but it's a good practice to continue. All right? Sounds good. Any questions so far regarding what we've done? All right. Let's do some rational expressions and equations and so forth. All right. Couple of things that I noticed. One of the problems that we have is factoring, and you really, you extensively cover that. There are a lot of lectures that we gave also. There's a video available and so forth. And at this point, you really have to just practice. The only question that, I thought it's worth mentioning is looking at this simple case. Just one piece I picked up. For most parts, students are doing okay with factoring, okay? But when it comes to the sign sometimes, they don't follow up to make sure it works out. So just to give you an idea, if you're doing the trial and error class, okay? This is x, this is 2x, because 2 is what? 2 is a prime number. Okay? Now, again, the trial and error. Now you're looking at C, right? And you cut it into pieces, right? You need the negative sign, and you need to go with 1 and 15. You need to go with 3 and 5. Is that right? So is there anything that might work?
I have 10 and 3.
10 and 3.
10 and 3. Well, I did it the other way. I multiplied the 2 times the 15. I didn't do the trial.
I'll go over that, but no.
Okay.
If you do the 10 and 3, the product is 30, and if one of them is negative, it becomes negative. So right away it's out of the picture. Because what you're looking at, you don't have x squared to say I'm going to look at c, and I need 10 and 3 would be a possibility. But you don't have that. We're going to discuss that in a second when we go over the next method. Okay? So we're going to play with the numbers. Okay? Something that might work. Anything works? Say it again. -5 here. And what? +3. Of course, remember what I put here. Negative sign meaning I got to give it only to one of them in order to see. Do you see that? Now, one might say, no, it's +5 and -3 because there were a lot of mistakes like that. See, when you have the choice of 5 and 3, one of them negative, you are fine with the first term and the last term, but you must check the middle term. Do you see that if you use +5 and -3, they don't work? But look at this one. If you use it the way it's put up here, this gives you what? -10x. This gives you what? +3x. And the sum is what you're looking for. That's how you check the middle term. This is the trial and error. And quite a few had those numbers reversed, had those signs reversed. And simply because they didn't check the middle term.
Did you switch the 2x and the x around? Like switch them around if you have it backwards like that?
Okay, so you mean 2x what?
Right,
2x plus -5?
yeah.
And x plus 3?
Yeah. If you had like switched the signs.
Okay, is this what, okay, switch what sign? Okay,
Like,
if we had plus here and minus here, that's what you're referring to, right?
can you just switch the 2 front?
Okay, this becomes, no, of course you can switch the 2, you mean put in the 2x there and
Yeah,
x.
but
Oh, yeah, it's the same thing. It doesn't change anything. If you put a times b or b times a is the same thing, which is the commutative property of multiplication, and that's okay. X, okay, so then let's look at this one and I again come back to that. If you're looking at this one, what is this? 10x, right? Looking at this one is what? -3x. Now the sum, this time is +7x. And that's the thing, you have to do it fairly fast. Now, but as far as the answer is concerned, if you wrote 2x plus 3 first, it makes no difference. Why? Commutative property. I think that was the question, right? That is the commutative property of what? Multiplication. Order doesn't matter. Okay? Does that work? AB equals to BA. So that was a common mistake when that multiplication and division was given to you. You only had to check and recheck your work. It really doesn't take long, class. Okay? Doesn't take long. All right. Let's look at, okay, actually, the next one is interesting. Let's look at 2 problems simultaneously. What's the difference between 1 and 2? What do you notice? Do you treat them the same? What's the difference?
On the other side.
You're mumbling in class, talk to me.
Oh.
I want to know what the problem is so we can address it and fix the problem. So, is number 1 identical to number 2? No. Obviously not. Good. Good.
Solving for X.
So go ahead.
You're solving for X on
Which-
the bottom one.
Which one?
The bottom one?
Number 2, you're solving for x. Whenever you're done, x is a number that you're hoping to get to. Or it may not have a solution. Or it may have 2 solutions, one works, one doesn't. Are you with me? I don't know. We're going to work it out. But clearly, in this case, we are looking for an answer for x. X is a number. What about the first one? Just you're adding, subtracting rational expressions, and the result is some other expression. Even if it becomes a pure number like 7, it is still considered a rational expression. Although it's a whole number and it's a rational number. Or if it becomes 2/3 for that matter. You are looking to put them together into a single fraction. Is everybody clear? And that's unfortunately a common mistake. Now, when you put them together as a single fraction, assuming the answer is a fraction, then you have the numerator and you have the denominator, which is called LCD, the least common denominator. Does that make sense? Because one of the problems was some people combined stuff like that, but they ended up with the numerator and they dropped the denominator. You can't do that. Some people treated it as though it was an equation. They ended up with x equals a number. Okay. This is just adding a bunch of fractions. It so happened it's a rational expression. So it involves a variable. All right. In both cases, we need to factor the denominator of each fraction. So x squared plus 11x plus 30. What is that? Factor it.
X plus 6. X plus 5.
So the final answer is supposed to be a single fraction, and you can write up, class, you can write up 1, 2, 3 fraction bars, and then put them into one, or do it right now. So you're raising each fraction such that the denominator is this. So this is, the first one doesn't change. Is that right, class? So the second one, what do you need for x plus 6 to become x squared plus 11x plus 30, or x plus 6 times x plus 5? What is missing? Do you see that you need negative 3 times x plus 5? Now, if we don't see it, here's what we're going to do. Do you see what happened to this fraction? We just raised it by a factor of x plus 5, and therefore we multiply the x plus 5 by the top and the bottom. So everybody can see this. And by the way, let me just write the denominator before. And write it as a factor, and keep it as such until we are done. What about this guy? You compare it with the LCD, x plus 6, x plus 5, the product. So what is missing here?
Plus 6.
Therefore, you need plus 2 times x plus 6, which, again, if we have a hard time seeing that, we can do this. Right? 2 times x plus 6. This is x plus 5. So we see why we are doing it. So if you learn the process and why you do it, you won't make that mistake anymore. So now, another common mistake. People come here and then what they do, rather than what is the order of operation? The order of operations says simplify, then move to the next step. Why do you have to simplify the top? Because a fraction bar is a grouping symbol. Everybody knows a fraction bar is also a grouping symbol. Why? It groups together the top, which is now separated from the bottom group together. So you can't say, I'm going to drop the x plus 5. Is everybody clear on that? Or for that matter, x plus 6. X plus 5 or x plus 6 is not a factor of the top. Because if it were, it would be x plus 5 times the whole parentheses. And therefore you can drop. Do we see that? Because that's a common mistake also. So, order of operations is really the key. A fraction bar is a grouping symbol separating the top from the bottom. Now, what is this? This is 4x plus 3 minus what? 3x minus 15 plus 2x plus what, 12? Okay. Now, let me rewrite this denominator again. Now, everybody give me the top.
3x.
So we have what? 3x. Let's see. 4x minus 3x is x plus 2x is 3x. Does that work? Continue. Positive 3, negative 15, positive 12, it just goes away. So let me put it in the middle. Plus 0. They cancel each other, right? So I don't write. We shouldn't write plus 0. We know what that means. But do you see the numbers? The constant at top, they cancel. Now I look at the final. When I'm done, then I say, is there anything I can simplify? Is there anything I can draw? And there's nothing in common. Now, do you have to multiply these two and write down x squared plus 11x plus 30? No. As far as I'm concerned, the answer is no. You don't have to. Okay? By any chance, if some instructors are interested in that, you want to go with that step. There's no need for that. Is everybody okay with the first one? Go ahead.
After I factor the first part of the question, after I did that.
You're talking about the first denominator?
Pointing at-
How do we factor it?
No, after I did that, I multiplied
Okay.
everything by.
After you factor this, you will look at this denominator. What is that? X plus 6 and x plus 5. This is x plus 6, this is x plus 5. So what you're looking for now, what is the LCD? Now the LCD is simply x plus 6 times x plus 5. So after you factor every denominator, now you look at LCD. What is my LCD? Then, if after we find the LCD, every fraction must be raised such that it has the least common denominator. Okay? Now you can do it with 3 fraction bars, or one fraction bar will do the job as you're doing with numbers, right?
Well, what I did was multiply both of them, the x plus 6 and x plus 5, to everything to cancel out.
Okay. The problem with that is that you're assuming that LCD is not x plus 6 and x plus 5, rather x plus 6 squared and x plus 5 squared. See, this piece doesn't need x plus 6 as it there. Do you see that?
Yeah.
So you must multiply by x plus 5 only. This piece doesn't need x plus 6, x plus 5. So you need x plus 6 over x plus 6 only. If you do that, that means you are not considering only x plus 6 times x plus 5 as the common denominator.
Okay, I get it.
So it's very important to pay attention to LCD. Class, just a simple case. If you're looking at 1 over 10 plus 1 over 15, please pay attention. Can I assume 10 times 15 is a common denominator? Yes. Is it a least common denominator? No, that's what we are looking for. in intermediate algebra, I can't say, okay, I'm going to use 150. If I use 150, and if I'm consistent, I will come up with the correct answer. Because at some point I have to do a simplification and put the final answer in a lowest term. However, that's not the proper way of approaching it. So find the LCD first and check and recheck, making sure the LCD is correct before you move. Sounds good? All right. So is number one done? So the number one gives you okay. The final expression that it gives us is this, which has a numerator and a denominator. Okay? Now we're going to move to the second one. So let's see how we approach the second one. So everybody's done with that, right? Maybe I'll leave that because so we can see the expression. Again, you need to factor every denominator. We already know the answer. Now, what would be the easy way to handle a rational equation? You multiply both sides by what, everybody? LCD. Now, what is the meaning of a huge pair of brackets, multiplication by that? That means every piece gets, this gets multiplied by that, and this one, and so forth. Do you see, let's start with this one. Do you see if we multiply the first fraction, we get the numerator only, right?
Yes.
Now, before you do that, by the way, that I took off 1 point for that mistake, so let me just mention that. Before even you start, what is it that you need to exclude? You have to exclude what? -6 from here, -5 from here. This one is the same thing, this one is the same thing. So first and foremost, right, x can be -6 and -5. And the reason why, because at the end, when you check your answer, if any of them shows up, that's out of the picture. And that's called an extraneous solution. You remember that? And that was worth 1 point. This is important to mention. I think only one student. Pay attention, x can't be those. Does that make sense? And do we see why? All right, now look at the second fraction, everybody. Minus what? 3 times x plus 5, yes? What happens to x plus 6?
It's cancelled out.
It drops. And by the way, if it helps, write it as a fraction. So you have the equality sign, hold on to that. X plus 5 drops, 2 times x plus 6. And now simplify the left, simplify the right, and check the answer that you come up with. But this is pretty much, this is as hard as it becomes, this step, getting rid of all the denominators, and then it becomes a simple case of a linear equation, maybe a quadratic equation, something fairly simple. In this case, you have 4x plus 3 minus 3x minus 15 equals 2x plus 12. Is that right, everybody?
Mm-hmm.
All right. So now what? 4x and minus 3x. What do we have here? Let's put it here. X. Positive 3 and negative 15. What do we have? And the right side, just write it. Is everybody with me? Can I drop the 12?
No,
No. Excellent. Why not?
because you have to add it to the other side.
You don't have identical numbers 12 and 12. You have one of them which is negative and one of them which is positive. So you can't say they are identical and then drop it. So what you do, you can take this to the other side, becomes negative 12. This one to this side becomes negative x equals 24. Or you can bring it to the right. Right or left makes no difference. If you take it to the right, you have the answer in one shot. And so negative x equals 24. I did that on purpose because negative x equals 24, we are not done. If I had taken it to the right, in one shot I had the answer. And so x equals negative 24. Okay, I'm okay, right? It's a good practice. If you are consistent and you trust your work, all you have to do is check with that. If you have any doubts, you really have to go to the original one and put number 24 and check your work, making sure the left side and the right side are identical. You check your work, always, class. Okay? All right. I want to look at a word problem, and also I want to mention one of the word problems that students did, most everybody was okay. When we looked at the integers, okay, the question was if we have a couple of, we have two, what was it, consecutive integers, and the reciprocals add up to something, find those integers. That was one of the questions, right? All right. So if you have that one, and let's assume, I'm going to assume you can solve it because most everybody who attempted it, they did a good job. So it was fairly simple. But if you come up with the answer, and let's say the answers are, I don't know, 7. In fact, let me make it even negative. Negative 7 and 4/5. So that's one answer. After you're done solving, x becomes negative 7 and x becomes 4/5. Are you with me? So we are looking for two integers, and for that consecutive integers, such that the sum of their reciprocals is whatever that we mentioned and we were working on it. Now, do you see why we crossed this out? And by the way, that was, you solved for x and you ended up again. Do you see why we cross out 4/5? Anybody? Let's say we went with that question. The question had two answers, and one of them was x equals negative 7 and x equals 4/5. And we said this is out of the picture. Can anybody tell me why I crossed this out? Anybody? This is not an integer. Not an integer. So I hope you realize the importance of knowing different numbers, and I went over that from the basic natural numbers all the way to complex numbers. Do you remember that? I suggest you review that. And you're not done. You're looking for consecutive integers. So if x is minus 7, x plus 1 is what? Minus 6. Okay? If x is 8, x plus 1 is 9. So write both numbers. And then check. The reciprocal is 1 over negative 7 and 1 over negative 6. I'm going to get work looking at. All right? So that was one of the mistakes I noticed. Common. All right. I want to pick up a question and look at from the text, page 408. If anybody happen to have the text, can go to that page. I will read the question for you. All right, so here's the deal. We are looking at a motion problem, everybody. It's somewhat different than what we did, but you know, it's a class of problem called motion problem. And the problem that you were looking at, make sure if you have a question, by all means, you ask. So, a car and a train leave Union Station in Washington, D.C. at the same time for New York, 390 miles away. So, what we have a car class, and we have a train, and both of them are going to go from point A to point B. Everybody, doesn't matter where to where, it's just from point A to point B. Both of them going A to B. Are you with me? Okay. And what is the distance? Anybody remember what I said? The distance was 390 miles. So everybody can see that the distance is the same for both cases. By the way, whenever you do word problem, besides checking and rechecking your work, at the end, you want to make sure you answer the question in the sense that, are you answering the speed? What is the rate? What is the time? What is the distance? What is it that they ask you to answer? Okay? Because in that case, some students came up with the correct answer for the time. And they didn't know what the distance was, or they didn't write it down. And here's the reason. Whenever you finish word problem, write the units. The units will help you see what you're doing. So, a car and a train, one more time, leave Union Station in Washington, D.C. to go to Rochester, New York, 390 miles away. So for now, we're going to go from point A to point B. Both of them cover 390 miles, two different vehicles, car and a train. And so here's what's going on. If the speed of the car averages twice the speed of the train, just write this portion of the sentence. If the speed of the, let me continue and then you know. If the speed of the car averages twice the speed of the train and the car arrives 6.5 hours before the train, find the speed of the car and the speed of the train. So, what is given? The relationship between the two rates. So, here's the thing, one more time. If the speed of the car averages twice the speed of the train, okay? So, what is the speed of the train and car? The speed of the train, the speed of the car, I don't know. It's not given. But the relationship is that if this is x,
2x.
this is 2x. Now, what are the units? mph. That's what they said, miles per hour, right?
6.5.
Watt. And this is in hours, so we want to make sure we have the right. Now, when that happens, the car arrives 6.5 hours before the train. Okay? The car, let me just write. Okay? Is everybody with me so far? We want to solve this problem. And we have this piece of information. So now, look at this table. We have the distance, we have the rate, we want to look at the time, yes? What do you think? Give me some idea. Again, in this case, specifically, it's dealing with rational equations. But there are a number of ways to do it. Let me see what comes to your mind. Any ideas?
X plus 6.5.
Which one is x?
Train.
And why x? Didn't we use x?
So
So you
T,
can't use x anymore.
T,
So let's say t. And I'm not going to write that, but I will explain it since, actually I write it, but I take it a bit. So which one is t?
train,
The train is t. What about the car?
T minus.
This is t minus 6.5. Yes? If you went this route, multiplication of these two is 390, x times t is 390. Everybody agrees with that? What have you done? You have introduced two variables, right? It's the system of equations. But here's the problem. Is this a linear system of equations? And by the way, this can be solved. This can be solved easily by the method of substitution. But do you see that this gives you 2x times t minus 6.5 is 390. This gives you x times t is equal to 390, right? Since you brought it up, I'm going to quickly tell you the method, but I'm not going to, even write it on the board. Can it be done? Yes. How do we do that? Substitution. You say xt is 390, solve for x or solve for t, put it up here. I wouldn't go that route. Say it again?
Wouldn't it be like fractions, like if you need to get time, you divide?
Exactly. That's what I was at. Yeah. Again, can it be done this way? But we won't. Okay. Is everybody clear? So you were talking about the fraction. Go ahead. What do you have in your mind?
Well, to get the time, which is what we need, wouldn't we divide the distance by the rate, or?
So you mean this,
Hold on, I have to write it out.
right, class? Everybody can help out. T is d over r, isn't it? So what is the time for the first one? Everybody agrees with that? And what about this guy? Now, this is a function of one variable, namely x. And we know there is a relationship because they said so. All you have to do, now make up an equation or remember what you put on here. Is everybody with me? But one easy way to really never ever make a mistake, look at the concept of before and what it means, or after and what it means as far as time. So what do you think is the equation? And then I'm going to give you my thoughts as to how you easily come up with the equation. What's the difference between the two? The difference is how many hours?
6.5.
Everybody agrees one minus the other. The only thing is which one? Is everybody with me? Either 390 over 2x minus 390 over x, or 390 over x minus this one. Let me write both of them. Number one. Either this one or the other way. Right, class? Number two. Everybody agrees. It's very simple. There's a difference of 6.5. Everybody knows that. The difference is 6.5. Either I have to write the first one or the second one. That's fairly simple. In fact, I highly recommend you write both if you have any doubt, until the doubt is out. And convince yourself which one and why. What do you think? The first one or the second one? Do you see why the second one? Here's a simple justification so you never make a mistake. Which one is going faster, which one is going slower? The car is going faster, the train is going slower. Do you see that the one that goes slower takes more time. Therefore, this number is larger than this number. Justify it that way. If you have to write both and then check your work, and you can easily come up with a logic that says the first one makes more sense. Here's the second reasoning, okay? That might help too. If you have two fractions, everybody, where the top numerator happen to be the same, but the denominator, one is smaller, one is larger, are you with me? Which one is larger or smaller? Let me just give you numbers and then I come here. If you're comparing 7 over 5, we want to compare it to 7 over 2. Remember, in order to compare, you have to come up with LCD. Do you remember that? But if you happen to have identical numerator, intuitively you should be able to tell which one is larger. Is it the first one? Or is it the second? Which one is larger? The second one. See, some people said the first one. Why? Why is this the case? Isn't this denominator larger than this denominator? The larger the denominator, the smaller the fraction, right? So, which one is larger? 2x or x? Okay? And you subtract this. All right. So, 2x is larger. 2x is larger. So, it's a smaller fraction. Are you with me? The larger denominator. So, the second one we are going to deal with. I'm going to erase this, everybody. And so, again, 2x is larger. Therefore, this fraction is smaller. So 390 over x minus 390 over 2x is equal to 6.5. So what is the LCD, everybody? 2x. So I'm going to multiply by 2x. If it helps, I'm going to write 2x over 1. So 2x over 1 times 2. Do you see the x cancel out? You get 2 times 390, yes or no?
Yes.
Do you see that 2x cancels out? You get 390, yes? Do you see that 2x gives you what? 13x. By the way, since we know algebra and even arithmetic, can you see just without even calculating this is 390? There are two of them, there are one of them, so it's 1 times 390, right? Or just do the arithmetic. And divide by 13. What's the answer? X is 30. And that was the train. Remember that? The rate or speed by which the train is traveling is 30 miles per hour. The car is doing what? 60 miles. Okay? Now notice, this question didn't ask the time for each case. Is everybody with me? They didn't, fine. But if they did, we could easily answer it. Now that we have the x, right? And that's the idea. All right. Is there any question, class? This is the synopsis of the exam. And I highly recommend you go over this. If you're uncomfortable with video, they got to put it online. And you should have no problem with the exam. Do the exam, you have to redo it, right? You have to make sure every question is done right. And that, then of course, you know, a review at class for your own good. It will really help. If there is any more question, of course, you're more than welcome to. After you go over it, you're more than welcome to come and ask, and you go over it again for your whole class. All right? Have fun.